Okay, so number 10 says find the greatest four-digit whole numbers that has exactly three positive factors. So we're looking for a four-digit whole number with three factors that has exactly three factors. Okay, so what we're gonna do is go back here, and I have an instructor tip, and it'll make sense here in a minute why we have to do this work. It looks like a lot of work to answer one question, but it'll be worth it. So, um, we're gonna look at these numbers, okay? So here's the number, three, okay? And what are the factors of three? So when they ask you what's a factor of a number, you're looking for numbers that divide it. Now, three is prime, right? So the only two things that divide it are one and three. By the way, just to remind us of the problem, we're looking for a four-digit number. So it's gonna be something in the thousands place that has only three factors. And we're looking for the largest one. Okay. So what I want you to notice is three has two factors, right? It's only one and three. Okay. Now four is divisible by one. Four is divisible by two, and four is divisible by four. There's nothing else that divides four. Like three doesn't divide four, right? So there's three over here, so I'm gonna put a three over here. So what I want you to do is to complete this table, and then we should be able to answer the question. Okay, so let's see what we get when we fill this in. So we've got six. So six is divisible by one, two, three, and six. Okay. Eight is done, right? Eight is divisible by one, two, four, and eight. By the way, usually they come in pairs. So, the one goes with a six and the two goes with a three. That's that's an important result. Now nine is divisible by one, three, and nine. So it has three factors, right? By the way, this one sort of comes in pairs because yes, one times nine is nine, but the middle one in this case, you have to use it by its times itself. So it comes in a pair, but with itself. Another thing that's another thing that's important to notice. Okay. 10 is divisible by 1, 2, 5, and 10. They come in pairs, the 1 and the 10 and the 2 and the 5. Look at 12. 12 times 1, 2 times 6, and 3 times 4. So that's 6 factors. By the way, 10 had what, 4 factors? Now 16 has 1, 2, 4 with itself. 2 goes with 8, right? And 1 goes with 16. So this is 5. 25 is divisible by 1, 5, and 25, right? So it's 3. And 49 is 1, 7, and 49. 3. So the reason I had you do this is because I want you to look at all the ones that are divisible by all the ones that have 3 factors, because that's what we're looking for, right? Now we're looking for a 4-digit number, but I want you to look at these numbers. No, I'm sorry, not that one. The ones that have the 3, and tell me or notice what do they have in common? Like, what's special about those? 4, 9, 25, and 49. So what are those? Those are perfect squares, right? You could do 2 times 2 is 4, or you could change this and do 3 times 3, and you get 9. And 25 is 5 times 5. 49 is 7 times 7. Now, there's one more thing I want you to notice, and then you'll be able to work on the answer to this problem. Notice now 16 is also a perfect square, but it has more factors. It has 5. So what's special about 4, 9, 25, and 49 is this, and this should allow you to get the answer. This number is a prime. This number is prime. This number is prime, and this number is prime. So what you're looking for is the biggest number you can make, where the two numbers that you multiply, let's call them P, are prime numbers. And you're going to look for the biggest prime that gives you a 4-digit number. That's how you approach that problem.